Much for giving me the chance to come here. I want to say from the outset, I am an academic. I am not in the publishing world, and I stress that because some of the things I'm going to say might be a little bit presumptuous or provocative, and I don't want to upset anyone. Just treat it as complete naivety of someone who doesn't know your world. Okay, so starting with this first slide. I'm trying to be deliberately provocative with the title. Of course we want to share data, and you've heard two great talks about that. We've also been involved with these, with at least some Simon's organisations, done a lot of work over the years on sharing data. But you know what we've learned from that is sometimes you can't share data. Often you can't share data, at least in our world of biomedicine. And so then what do? Do you give up and go home? No, you find other ways to move the field forward, and that's what I'm really trying to address here. In addition to sharing data as much as we can, since that's not going to always be possible, what else do we do? That's really the point of my talk. The other point I'd like to make is on my name. I was introduced just now as Tony Brookes. Please call me Tony, but I've put my name there as Anthony, because if I'd written Tony, you would have had two talks from J Brookes at this meeting. And that might have been a little confusing, especially when you write it up or when you try to connect the data and you don't have researcher IDs on these things. So, so I thought I'd make that point. But to make it clear, the J Brookes yesterday, he has no E in his name. He's also more successful than me, less good looking, but he does do knowledge engineering as well, which I'll be saying a little bit about. Okay. So I came here yesterday, saw lots of talks, talked to lots of people, and today also, and my conclusion is, and I put this slide in just a short while ago, is, wow, the things are changing so much for you guys. There's so much happening, and I'm blown away by what you're dealing with. It's incredible. But do you know what shocks me? I'm not seeing excitement and optimism and visions of how you can exploit all of this. I'm seeing paranoia, navel-gazing, angst, fear, anxiety, and I think you're missing the point. So I threw in another slide. Since I've seen so many wonderful quotes from wonderful people like Voltaire and so on yesterday, I thought I would put an extra slide in here from this guy. Probably know him, Bill Hicks. One of his most wonderful quotes is, in my view, hey, don't worry, don't be afraid ever, because it's just a ride. Okay, there's this wonderful little sketch he does on, you can get the YouTube video. You really should look at it. He really puts life in context. He makes it clear that it's all going to happen anyway. You're the people who are going to make it happen, so enjoy it. This is going to be a really exciting decade. In looking up this and just making sure I got his quote accurate, I found another one from him which I couldn't resist putting in case he was predicting something about the open access movement. He said, "It's all about the money, not freedom." Y'all okay? So I think that's actually also exactly what it's about. You have to make money out of this, and that's the challenge. If we were given massive grants to play with data and do all the things we want to do, that's easy. It's how you make business models out of it. So what you can do is play around with your current business models, tweak it at the edges, try to dissect it, try to understand it. That may get you so far, but what about just looking beyond all of that to what isn't being done yet? What can we do new? And again, that then brings me back to my talk here, my title. Let's think beyond data sharing. What else is there? So that's, I guess, my introduction about what the talk is about. Give you a sense of who I am. I'm a professor of bioinformatics and genomics in this wonderful new building. I took that photo on my mobile phone a couple of days ago, and it's come out terrible. But it's a cardiovascular research center. We've got a clinical expertise center floor. We've got a biobanking floor with robots moving around in freezers and all sorts. Research labs across another floor and elsewhere. And that whole top fourth floor is informatics knowledge management. We've put all that together from the research activities, from the healthcare, from the hospital IT system. The whole hospital's really buying into this. We've got IBM re-kitting out everything in the hospital, feeding data into us. So we're really looking at how we can connect research and healthcare data. A lot of this comes from a project I run, EU project called Gen2Fen, which is about unifying and getting the maximum utility out of data relating genotypes to phenotypes, genetic and disease data. And that's how it was when we started. Lots of resources out there unconnected. We've looked at how to connect them, how to bring it all together, and it involves lots of those kind of things on the right there. We've made a lot of progress in that field, and that's really where I've cut my teeth on understanding the problems around data sharing and beyond. So that's Gen to Fen, but that's not all I've done. That's not all I've been doing. That project has actually just now finished a few months ago. There's these other projects I'm involved in, gives you a sense of who I am. In total, there's about 100 million euros of money going into these projects, typically 5-6 year projects, and we're doing the IT on all of them with others. And you know, the same themes come up time and time again. And I really think there's a massive opportunity there for someone to really solve a lot of these problems that are coming up time and time again. Who is it going to be to solve those problems? It's not these guys. These guys have to solve their problems for their own data. We need a bigger approach, and I wouldn't be surprised if that could come from you, the publishers. And I'll say more about that later. So it comes down to this. How do we connect research and healthcare? We need a new domain of expertise called knowledge engineering. It's different to the knowledge engineering that the other J Brookes spoke about yesterday. And these are not data scientists. But I'm not here to talk about knowledge engineering. I'll point you to a paper on that. You can go and read that we published a short while ago about that. Okay, so that's who I am, and it gives you a sense of the kind of work the kind of data and issues I'm dealing with. Now for the main talk then. If we build all of those databases, build all of those standards, get it all in place, it's not going to work. It's going to be pointless unless the data flows through the system, right? So will the data flow through the system? Many people say, yes, we just got to build the system. Indeed, you know, it's just essentially a big engineering problem now. So we need lots and lots of standards so that the data can connect and interoperate and flow through the system. And people are saying, and that includes the consent, the ethics, the legal standards and so on, not just the technical standards. And indeed, just recently, you may have seen this, June 3rd this year, a whole bunch of big, important institutes, scientists and so on came together. It was initially 8 groups, but now there's well over 100. All the big names have come together. There's this white paper about creating a global alliance to enable data sharing in the biosciences. I think, personally, this is just like the early stage of the Human Genome Project. Enough people around the world coming together saying, yeah, we need to do this properly. Let's do it properly all together. And then in the Human Genome Project situation, there was about 3 years of pilot projects, discussions, workshops, before they put serious money into sequencing the human genome. So the idea is here that they'll all talk, have workshops, and then put serious money, build those standards, those technologies, and we'll all have optimal, maximum data sharing. I don't believe it. For lots of reasons, partly because I've been trying to do it with different communities and I've seen the problems up close. One example of those standards, the IDs we need. We need IDs on people, on databases, on data, on bioresources and so on, and we've known this for a while, and we've been trying to build them. Trying to get everyone in the world to agree to put these things together is very difficult, and there's been very little progress. I would say where most progress has happened is in that top one. DataCite, the DOI system. Why? Because it started off with publishers' data. The data is digitized. It is in your computers. It is under your control, and you want to exploit it. So you know to exploit it, you need to stick an ID on it, and that's why it's happened. There's been no resistance to it, only people wanting to make it happen. It's happened from your community. These other areas, there's been much less progress. Similarly, if we actually dig a bit deeper and look at how do we bring the data together within one field, within one domain, getting the data, you've just heard a talk about this, getting the data together, digitized, curated, structured, getting it passed to put it into databases, metadata organized, all the things you have to do. It takes a lot of effort, and you have to drill it down to individual specialities. What if you want to ask questions of those data? So you don't just want to make a big library with links, you actually want to connect the data and bring new knowledge to the surface, then you need to harmonize the data. That depends on each question. Each question you ask, you have to do a different harmonization process. So there's all sorts of complications there. But what if you want to integrate data across domains? Then you're into this big data challenge. It's very, very complicated. Just putting a few metadata standards in place and hoping it's all going to then happen, I don't believe it. But beyond all of that, and probably more important than all of that, because you could, whip people and push them in, bully them one way or another into playing ball, is this: the people don't want to do it, right? And this is the researchers. They're saying it's my data, I generated it, I need it for my ref, I need it for my next collaboration, for my next grant. Or it's the hospital doctor saying, I can't handle my patient's data. Or the patient's data saying, I don't want you to handle my data. Or the company, the commercial entity saying, this data's got value, I'm not going to share it. That's really the problem here. So there will be many situations where we cannot share data. Given that, what else do we do? So, first we make it easier for data to be shared. And I think the problem, what we can do there is actually look at how we think of data. This is how we look at it today. We think of, well, some data's okay, I don't mind giving that away, you can have that, we can share that. That's the tip of a very big iceberg. The rest of it, especially in the biosciences, where there's a lot of human data, identifiable data, to the extent we do share it, we share it via managed access systems. Well, let's just think about that a bit more. It's not open, it's not safe and risky data. There's actually a massive amount of data that is not highly risky or completely safe. It's somewhere in between the two. And people are probably going to let this be shared before they let this be shared. And there's all sorts of aspects to that we can discuss. But the bottom line is you could automate the access of those data, the sharing of those data, with an inbuilt ID-assisted control of who gets to it for what purposes. Right? So I think if we don't try to solve sharing of all of this in one go, and we slice it off down this pyramid, we'll make a lot more progress. For which we need IDs on the data, IDs on the people, IDs throughout the system, and speed pass type concepts. Okay, that's fine to improve and make as much headway as we can with sharing data, but I'm saying we should go beyond just sharing data and think about discovery of information and discovery of data and really sharing of knowledge. What do I mean here? Well, I mean, let's think of a world where if you want to know, is there any data out there of interest to me, there is a system for you to go and ask that question. And it will tell you, yes, there are data, and this is where it exists. Right? That, in essence, is the idea of data discovery. It's about sharing the existence of data, not the substance of the data. Okay? If you do that, you could set that up for all these types of data, and it could be open access in each case, because no one is risking anything. No one's giving anything away that they deem to be valuable. You're just allowing people to come into your systems and discover if you have anything of interest to them. It's advertising, it's promotion, it's what you guys want to do to get people to come to you and ask to pay for stuff you've got, right? So I think that's very important. It fits beautifully with the publisher's ambitions, and we've been showing that that can work in the real world. Not the real world of publishing, I hope to maybe have a chance to do that with you, but in the world of DNA diagnostics. So in that world, they are generating DNA mutation data on lots of patients with rare diseases, Mendelian genetic diseases, but they can't go and put that up there on the web. But each doctor that generates such data finds a mutation. They don't know how to interpret it. They'd love to know, has it been seen before in patients with a similar phenotype, similar disease? They can't access those data because it's not shared, because they don't want to share it. So we said, well, let's make it discoverable. And we've done that. We've, as I say, we've set up this system called Café Veriome for openly sharing the existence rather than the substance of the data. And thereafter, depending on the scenario, they variably manage data access. So that's all this bit says here. The kind of use cases would be where a group of labs with an interest in a similar disease might want to set up this system across themselves. And we've got that working now. And we're extending it to look at next-generation sequencing data, much more sophisticated phenotype data, and other things you can extend this system into. Give you a sense of how it works, just to prove it's not just vaporware. They come in with whatever query structure. This is our current interface, so you ask what kind of mutation, or what gene is it in, or what kind of resource are we looking for it in, or what group of labs are we asking it the question of. It then trawls across those, finds the hits, and then once it finds the hits, it could be that piece of data is that little tip of the pyramid. Yes, you can have it, so we return it. The data are then handed on to whoever made the request. That's open data sharing, fine. But in most cases, no, you can't just get the data freely. There are two ways to proceed. One is, it could be that particular user, requester, and that particular owner of the data have established a relationship, and that's in the system. It knows that. So in that case, you can hand the data on to that individual. In other cases, you can't. When you can't, the system springs up a request form for you to fill in and say, this is who I am, this is how I want the data, can I have it, please? And then that goes off automatically by the system. The owner sees that, says yes or no. They can either just start up an email discourse if they want, or they can say yes, in which case then it fires back to this system and the data are handed over a day or two later by email. So the system's there, it's up and running. Of course, the third option is, no, you can't have it. Here's a link to our web page. Come and talk to us. So it sort of goes ahead outside this system. That technology is all in place. It's been built in a very generic way so that you could use it for any domain. It doesn't have to be genetic data or phenotype data. The underlying technology is very general. this is the kind of result that comes back. Here's the different places we find data, and here's the different categories of result we get. 11 hits of this type in this resource, 100 and whatever hits in this resource of that type. So you get the idea. This gives you a sense of what we're doing now with these different countries. We're discussing, in some cases cases building this solution for all the diagnostic labs across their country. It seems that these diagnostic labs want to make data discoverable within a country before they let it outside their country. And that's what we're doing here. But also for certain disease-specific networks, we're doing the same thing. Final couple of slides. You can take this beyond discovery of data to knowledge sharing. What do I mean by that? Well, it's very easy to imagine now. When you see this number of hits here, 11, yes, in that particular, diagnostic lab, whichever, there were 11 hits that matched your query. 11 patients had the same mutation and a similar phenotype, for example. You could very easily say, not just 11, but 11 out of 55 people with that disease. Now you've got frequency data. Now you've got knowledge. You could equally get that result from one of these population frequency databases. And if that said, oh, that's 20% as well in the general population, you start to be able to conclude, well, it's not important for disease then. You see, if you don't ask to access the primary data, but ask to access the knowledge that's contained across those data, this system essentially is one step away from doing that. And that's the way we're now taking this forward within Café Verigone. But just to show that that can really work, in hospital data, where the patient clinical data are stored in digital form in electronic healthcare records, they're used for lots of things in the medical setting. There are the data. They are digitized, they are captured, but they are very private. You can't just hand them out freely. So a project called EUADR was running. It's now finished. It's now being taken forward by this EMIF project that I'm in. They're generalizing the EUADR systems, but these EUADR systems are already using this idea of remote knowledge sharing rather than data sharing to look for adverse drug reaction evidence across 30 million patients in real time. So it's very doable. Right, and it's exactly the same kind of concept. Have you got records of interest? Can you give me some summary statistics, some aggregate data from those? It's doable. It's done. The trouble is, it's only being put in practice in very specific situations today. How will it go forward from here? I don't know. But I think the world of publishing, where you're looking to go beyond just the journal article itself, you want to make use of the data, and you're not sure how to make use of those data. Other than creating libraries and depositories, big libraries of the data, how to connect it, how to make it useful, how to make people come to you and ask to pay for it. Some of these ideas I presented today might be of interest. So, in summary slide, yes, data sharing clearly is important, but it's problematical in many situations. I think by prioritizing the IDs that we need and risk categorization, that middle chunk of that pyramid, we can make a lot more progress. But would request you to start thinking more about data discovery, because you get 90% of the benefits that you do from data sharing and only 10% of the problems in setting it up. If you move beyond data discovery to knowledge sharing rather than data sharing, that's really just a technical extension of data discovery, but you now get 99% of the benefits of open data sharing. Journals. I think you guys can move this field forward just as you've done with the IDs, because you already do knowledge sharing based on free text. You are therefore best placed to start doing data discovery. I've mentioned that several times, several ways in this talk. Once you're doing data discovery, you can move on to knowledge sharing, not as you do now of just free text in articles, but the knowledge that's encompassed within the data, across the data, different data sets. And maybe that allows you to become the future, where the world of databases and the world of publishing journals merge and become, call it database journals, call it whatever you like. Maybe that's the new business model type thing that you should be thinking of, instead of just trying to tweak the current business model around the edges. That might get you more excited about things and less paranoid and take away some of the angst and sleepless nights you're probably having. I hope that's been inspirational. If it's been presumptuous and annoying, I am an academic. Give me some leeway. Thank you very much.